let's now define the constant multiple rule, which it says here that the derivative of a constant times a function is the constant times the derivative of the function. That is, if y is equals to f of x and equals to the constant times the function f of x, then our dy over dx, or our derivative, is equals to the constant times the f prime x. Let's now prove this definition. We let f of x is equals to the constant times f of x. Then we have d of x, d of y over d of x is equals to f prime x. Now our f prime x is just the limit of f times x plus h minus f of x over h, where h approaches to 0. Since we let our function is equals to the constant times f of x, we now have the limit of constant times f of x plus h minus the constant times f of x over h, where our h approaches to 0. Then we move the constant to the left. Here, c times the limit of h equals 0, f of x plus h minus f of x over h, where our h approaches to 0. And now we have c times f prime x. Notice that this equation is just equals to our formula f prime x. So that's it. Let's have an example. Let's find the derivatives of the following. Number 1, we have d over dx times 4x equals to 4 times d over dx x cubed by the constant multiple rule. Then next we have 4 times 3x raised to 3 minus 1 by the power rule. This equals 4 times 3x squared, which which is now equals to 12x squared. So our next example is p over dx times negative 5x to the fourth power. Now we have negative 5 times b over dx x to the fourth by constant multiple rule and negative 5 times 4x raised to 4 minus 20 by the power rule. We now have negative 5 times 4x cubed, which is now equals to negative 20x cubed. So that's now the constant multiple rule in our basic differentiation technique.